high-performance liquid chromatography or HPLC is a powerful analytical technique used in chemistry for separating, identifying, and quantifying components in complex mixtures. It operates by passing a liquid sample through a column containing a stationary phase under high pressure, resulting in the separation of compounds based on their interaction with the column. In this experiment, we use HPLC to analyze the caffeine content in soft drinks such as Coke and Levita. Caffeine, a naturally occurring stimulant, is commonly found in beverages and requires precise quantification for quality control and regulatory purposes. By preparing caffeine standard solution and soft drink samples and operating the HPLC instrument, we determine the retention time, peak area, and concentration of caffeine in these beverages. The objectives of this experiment are to understand the principle and operation of high-performance liquid chromatography. Second, to prepare and analyze caffeine standard solutions and soft drink samples using HPLC. Third, to determine the retention time and peak area of caffeine in the samples. And lastly is to calculate the concentration of caffeine in soft drinks using the response factor method.
Next, I'll be talking about the methodology. First part, I will introduce about instrument block diagram. First, we have solvent reservoir, pump, injector, guide column, analytical column, detector, and data system. Next, I will talk about the function of the instrument. First one is solvent reservoir. It stores the liquid mobile phase in solvent used to carry the sample through the system. Second, pump. It pushes the mobile phase through the system at high and constant pressure. Third one is injector. It introduces the sample into the mobile phase. Fourth one is guard column. It protects the main column by removing impurities and extending its lifespan. Fifth one, analytical column. It used to separate the component of the sample based on their interaction with the column packing material. Next, it's detector. It's to identify and measure the separated component as they elute from the column. Last one is data system. It records and displays the result as chromatogram, which is a graph of component separation.
Moving on, this is the result that we obtained from the graph. We can see that the retention time for caffeine standard is 2.482, for Coke is 2.481, and for Levita is 2.479. Meanwhile, for the peak area of caffeine for caffeine standard is 6249.48779. For Coke is 7001.12305. And lastly, for Levita is 2389.66479. Thus, to determine the concentration of caffeine in the soft drink sample, we can obtain this formula of response factor RF, caffeine standard, and concentration of caffeine in the lab manual given. To determine RF, we use the peak area of caffeine standard divided by concentration of caffeine standard, which we can get RF equal to 6249.48779 divided by 100 ppm, and the answer is 62.49488. Next, to determine the concentration of caffeine in Coke, we use the value in the peak area of caffeine in Coke, which is 7001.12305 divided by the total RF obtained, which is 62.49488, and the answer is 112.027 ppm. And lastly, to determine the concentration of caffeine in Levita, we use value in peak area of caffeine in Levita, which is 2389.66479 divided by the total RF obtained, 62.49488. Then we can get the answer is 38.2377 ppm.
For discussion part, first, high-performance liquid chromatography is an analytical method employed to separate, identify, and quantify the components of a mixture. The separation process relies on the fundamental principle of column chromatography, followed by identification and quantification through spectroscopy. Second, by using the relationship between concentration and peak area, the caving concentration in the soda sample can be determined. The caving peak appears after the second, and by comparing it to the caving peaks from standard solution, the amount of caving in the sample can be calculated as the caving concentration increases. The area under the caving peak also increases, indicating a higher caving content in the mixture. An experiment was conducted using high-performance liquid chromatography to identify and quantify caving in a soft drink sample. Standard caving solution with varying concentration were prepared and analyzed by HPLC alongside the soft drink sample. The HPLC technique separated the mixture into its individual components, and caving in the soft drink was identified by comparing its retention time with that of the caving standard.
So for the conclusion, this experiment have determined the retention time of the standard solution of caffeine, which is 2.482 minutes. Then the caffeine retention time in the soft drink sample, which is Coke and Libita, have been identified, which Coke is 2.481 minutes while Libita is 2.019 minutes. Then the caffeine peak area in soft drink sample, which Coke and Libita have been identified, which Coke has 57.36% and Libita has 70.70%. Next, the amount of caffeine in soft drink sample has been determined by using the response factor method. The concentration of caffeine in Coke is 122.027 ppm and Libita is 38.2077 ppm.